Hey guys, welcome to a new series that I'm just starting. So this is a series about design patterns, right? I will, pick each design pattern, each very famous design patterns, and then I will try to break them into what are the types of it, and then we will go on and study about each of them in detail. We might look at some code, we might look at some theory and stuff like that, right? So let's get started. So essentially, what are design patterns, right? So design patterns are essentially, if in the software industry there are very common problems that is being solved across various softwares, right? So if a problem has been solved already, then we want to reuse that. For example, if there is a pattern that helps the pattern that helps keep your software more maintainable, keep your software more readable, and scalable, then that pattern can be used in other softwares as well, right? And this patterns and this design patterns have been developed by like have come into practice through years of kind of practice of software engineers, and then they have realized that okay, these are the patterns that can be frequently used, and yeah, these are like very known famous patterns that developers should be aware of, right? These are not like a rule book, but good to be aware so that you can don't invent it yourself, right? You know it and you just go and kind of implement it, right? And yeah, so as we discussed, right, there are several benefits to design patterns. One of the other benefits is that it provides us a terminology. For example, if I'm talking to a fellow developer, then I tell him that okay, can we use let's say X design pattern to solve this problem? Then that developer knows what X design pattern looks like. I don't have to give him a code sample to make him understand what this looks like, right? So that provides a common terminology to it. So that's the kind of crux of what design patterns are all about. And now let's see what are the types of design patterns. Okay, so like broadly speaking, right, there is creational design pattern, and then there comes structural design pattern, and then there comes behavioral design patterns. So these are like the broad level design patterns that we will be studying. So let's get started with the creational design pattern first. So creational design pattern, for example, the what are the types of creational design pattern? So there is like builder design pattern, there is singleton design pattern, right? There is some sort of factory and abstract factory design pattern. So and yeah, like the list kind of goes on and on, right? So creational design pattern essentially helps us with simplifying the creation of object life cycle, right? How the objects are created, right? That's what creational design pattern helps us with. So let's get started, and we will be studying our first design pattern, which is the builder design pattern in this particular video. So let's really dive deep into it. Okay, so when and how do we use a builder design pattern, right? So we're talking about this particular thing called builder design pattern. So right, so this stuff, right? Now, so when there's a complex process to construct an object, right? And so basically the process to create an object is not straightforward, right? There are multiple steps to it. When we say multiple steps, it can mean various things. Like it can also mean that okay, there are a lot of parameters, right, that we need to pass to the constructor, right? Parameters that we need to pass to the constructor to be able to create this object. Another thing can be okay, this object depends or takes as an input another object, right? Let's say this takes in input as another object, let's call it object 1, and this is passed to the constructor, and both of these complex objects are complex. Then we need to first create this object and then kind of pass that to this particular object. So you see, right, there is a complex process to construct the object and it requires multiple steps, right? And what are these steps, right? How do we create an object, right? First thing is, right, we need to identify the parts. We need to identify the parts needed to create the object. When we say parts, it usually means the constructor parameters, or the kind of the parameters that this object holds, right? We need to identify that, right? And then we need to assemble the object. What do you mean by assembling the object? So basically, if we have a kind of let's say we are building an kind of a object, right? Then it can, how do we say assemble? Okay, so we have put, let's say this, like we have put the one parameter to it, we have given the second parameter to it, we have given the third parameter to it. Now at this point we need to assemble these three parameters. So like the example that I'm trying to take is that of a product, right? So if you're building a product, then it can have multiple parts. If you're building a car, you can have multiple parts. So once, for example, you have put the engine, then you want to assemble it, right? But like initially when you just have the engine, you cannot just assemble it. Okay, so after the engine you put another part to it. Let's say you put the gear to it, right? Then you can assemble the gear, you can assemble the engine, right? Stuff like that. So for example, there is a car which has kind of what we call, let's say, the wheels to it, right? Then after putting these three, we want to assemble it. But there's another type of car which has particular feature which is just specific to the car. For example, like this is a Mercedes and it needs a logo. So this will be an additional step to it, right? So certain cars don't require all the features, certain cars require some of the features. So like there is no straightforward process to construct the object, and at any moment we might want to assemble it. For example, so like we assemble the object, and then once we assemble the object, we want to get the fully built object out of it, right? So this is how like we break down the builder design pattern. I know this is kind of a bit confusing, but I'm just trying to keep it very simple for beginners as well. So once you understand this completely, I might kind of try to create a series where I explain the builder design pattern in more detail. But yeah, summing up, object creation simplifies the object creation object when the process it becomes kind of difficult, right? And has multiple parts. Then we identify the parts, we assemble the project object, and then kind of build it and return the fully built object, right? So let's take a quickly simple example, right? I won't make it much complex. So for example, okay, since we're talking about the car example, let's take that. Okay, so we have a car, right? And then basically we will have a car builder which will help us build this particular car, right? So any client which wants to build a car, which will they will use the car builder to set the parts of the car, right? It won't be using the setters of the car. It will be only be allowed to use the car builder to assemble and build the car, right? But in a complex case, what could happen is that car can be a kind of a interface, right? And then there can be various types of cars, right? For example, SUV, there can be sedan, and then there would be separate car builders for each of these. So basically car builder will also be an interface then, and then we will have like the SUV builder and the sedan builder, right? Stuff like that. So this is how it can get more complex, but we will keep it simple for now and just see a very basic example to start with. Okay, hope this makes sense. If you have any questions, just post it out in the comments. Okay, cool. So now what happens is that we go back to our drawing board and see how we can implement this. Okay, so I have this example that I've created, right? I will just walk you guys through it. Yeah, so okay, I hope this is visible, but if not, let me try to fix this. Okay, so I think it would be more visible now. So basically, like I've pre-created an example. So let's say you have a car, and right, it has various properties like the make, for example, Toyota or Maruti. It has a model number, it has a year, it has a color, right? So this is like the car that we want to build using the builder design pattern, right? And I have marked the private constructor for it. The reason is we don't want to really use the constructor to build the car, because like it can get complex, right? Let's say car had 10 other properties, right? Then we don't want to pass all the 10 kind of properties here, right? We don't want to do that. We don't want to pass 10 properties here. We don't want to do that. What happens if this car doesn't have any property, like for example private, logo, right? Some sort of logo. This car, let's say, doesn't even have a kind of a logo, right? Then we don't want to pass null for this particular logo in the constructor, right? That really defeats the purpose and it makes the code less readable and kind of ugly, right? So like this is a simple example, but I hope you're trying to understand when this process becomes much complex, then how does this making this constructor private and the builder design patterns comes into picture and really helps you, right? So we have like public getters for this particular car, which is all fine, and then we have another method which is like the car builder, right? So basically car builder basically get builder, what it does is that get returns you an instance of car builder. Car builder is another class which is static class, static class member of the car itself, right? So what happens is that this is a good way to implement the builder design pattern. You have a static builder inside the original object that you want to create, so kind of it really gives a good namespace to this particular car builder. So this is car builder, and really makes the process of the client to understand where does the builder exist really easy, right? It doesn't have to search for it, right? It knows like car builder, something like that. Okay, so we have this car builder, and this get builder returns an instance of car builder, right? And we have this static class car builder, so that we can access the car builder using the original parent car itself, right? So it has like private fields, right? Because we don't really want this to be exposed to the client, because these are usually attributes, really the attributes of the car and not the kind of the car builder. So what happens is that this is what the assemble part I was talking about. We are assembling the car with first the make, and then we can assemble like method to assemble with model, with year and stuff like that, right? So this is how we implement like the builder assemble part of it. We have public car builder, right? It returns a car builder. So remember, this returns a car builder, so that once you have added make to the car, you can also build it on top of it. You can use something like which is called method chaining, right? So what happens is that I will show you below, but like this is just to facilitate method chaining. So once you have called with make, whatever you are returning is the car builder, and then you can also do dot with model, right? So that's why we are returning the car builder and not the car from here, right? So yeah, and then what happens in build method is we create a new car, we create we get whatever is built, for example make, model, year, color, whatever the client has set using the with year will be present here, right? With color, with year, with model, right? And then we just set this to the car and then return the car. And then if you see how we can test this out, is this is like a example. Then in main we have car builder, as we said, right? This is the namespace car builder that we give to the builder class. We get the builder, so essentially this is the method where we were returning return new kind of in get builder. What happens is that we return a new car builder, right? So this is what is done in this method, and then we just build a car. How do we build a car? We say builder dot with make this, with model this, with year this, with color this, and finally build, right? And then we can just print out. What happens is, let's say tomorrow we don't need the year, we just remove this, nothing breaks. Tomorrow we don't need the what model, we just remove this. We don't have to change the constructor, we don't have to add any other constructor. This works, this solution works, right? So yeah, I will have this and just show you quickly running and showing how it looks like. So you can see, right, the car has the make, model, year, color, right? And if I remove this, what happens? Guess what? what happens? This is 0, this is nothing changes. We haven't changed the constructor. I hope this stuff is visible. I can just scroll up a bit, example of a builder design pattern. uh, so that was mostly about for this particular video, but like a good example of a builder design pattern is like the string builder class in Java. It internally uses the builder design pattern. So yeah, that was about it. In the next video we will be learning about the factory design pattern. So stay tuned, please give the feedback in the comments. This is kind of the first video that I'm making after a while, so hoping to improve as I go, and would need your support to direct me in the right direction. What should I improve? How's the video quality? How's the audio quality? What topics you want me to teach? Stay tuned. All the best. See you guys.